Lesson 2.8, we are going to work with inequalities. We're going to decide whether given ordered pairs are solutions to a certain inequality, and we're also going to graph them. So you need to shift gears a little bit here. We're talking about graphing inequalities, not graphing equations. So we're not going to just have a line. We're going to have a line, sometimes dotted, sometimes solid. Okay, this should be a review from Algebra 1. Sometimes it'll be dotted, the line, sometimes solid, and then we're going to need to shade either under or over the line or to the right or the left, depending on the inequality. So if we're looking at number 1, they want to know if those two ordered pairs they gave us are solutions of the inequality. So we have to check both of those to see if they are solutions to the inequality. So we're going to do that by plugging in x of 5, y of 4 first. We get 1 is less than 4. That is a true statement, so this is a solution. All right, so the point 5,4, this first point right here, is a solution to this inequality. We'll do the same thing with the other point. Plug in at the accurate x and y, but that's negative. 3 is less than 4. That is also true. It doesn't have to be. I mean, one of them could be yes, a solution. The other point could be no, it's not a solution. But in this case, both of these are solutions to this inequality. All right, we'll do the same thing for number 2. So number 2, plugging in those values, I'm going to check that first ordered pair. I'll end up with negative 3 on this side, negative 3 on the other side. And now this, at first glance, could be tricky because negative 3 is not less than negative 3. However, this is a less than or equals to. It just has to satisfy one of them. So if it's not less than, we have to check the equals, and we do know negative 3 is equal to negative 3, so this is a solution. That means when we graph it and we shade in the appropriate section of the graph, 0, negative 1 will fall either on the line or in the shaded portion of the graph. We'll do the same thing with that second ordered pair they gave us. And there's no reason that they're giving you 2 ordered pairs. They're just having you practice it twice. It's not, it doesn't have anything to do with the concept. You could check more points. We're just checking these 2 just to get a feel for how this works. This is not a true statement. 0 is not less than negative 3. It's not equal to negative 3. So this is not a solution. So this data point, this ordered pair of negative 3, 2, it will not fall in the line of this graph. It will not be in the shaded portion of this graph. It is not represented in this graph. It is not a solution. All right, moving down to number 7, they want us to graph that inequality. So x is greater than 2. You need to think about it first as what would you do if it were x is equal to 2? If it were an equation and x was equal to 2, you would go to x of 2 right here, and you would draw your vertical line down through that point. Because no matter what the y is, x is 2. In this case, because x is greater than 2, but it cannot equal 2, we have to draw a dotted line. All right, so hopefully this comes back to you in an inequality. When the inequality states that it is not equal to that value that's on the right-hand side, that you indicate that with a dotted line. It means x cannot be 2, but then the boundary is anything greater than 2. So we would shade in here over to the right, because that shows us values of x that are greater than 2. We're looking at that x-axis and going to the greater than side. On number 9, before we can do anything, we have to solve for x. So we've got to divide by that 2 on both sides, and we'll get x is less than or equal to 4. So if x were equal to 4, if this were an equation, we would go to x of 4. We would draw our vertical line in. And in this case, x is either less than or equal to 4. So this is going to be a solid line down through here, because x could be 4 according to this inequality. But we have to acknowledge the less than part. It could be equal to 4, but x can also be less than 4. So we would shade in all over here as well. On number 12, same thing. Now we have y though. So we were going to have to solve for y by multiplying both of those sides by 4. That'll get rid of that fraction for us, and we'll have y is less than or equal to 4. And so now, if it were y equals 4, we would go to y of 4. We would draw a solid line in. We're going to do that anyway because we see that y can equal 4. It can also be less than 4 though. So the line tells us it can equal 4. What we're going to do is shade under for less than 4. And now I'm looking at that y-axis, and I'm saying all values that are less than 4 are going to fall under that horizontal line I graphed. On number 14, we need to graph that. Now this is has a y-intercept of 2, and then we've got our slope of 1/2. So I'm going to graph this as though it really said y equals 1/2 x plus 2. This is just a y equals mx plus b equation right now. Think of it that way. Put your y-intercept in. We've got a slope of up 1 to the right 2. And then I'm going to do it again. I'm just going to go down 1 to the left 2. Okay, I'll put my line in. Now it's solid because our inequality symbol says that y can equal this graphed line. It also says y can be greater than. So then we would come back in after graphing and we would shade above, because the y's that are greater than this line are going to be above on the graph. Now, number 19 is an absolute value inequality. So we're going to graph it like it is in an equation. All right, so the absolute value inequalities or equations take this form, where hk is our vertex, and that a is going to be our slope, whatever that value for a is. So we can look at number 19, and if I write that in under here, I'm going to have a less than sign instead of equal. That's okay. I'll show you how to do that. We only have to deal with that when we go to shade. The h is not written, just like when we don't write down our b in y equals mx plus b, then it's a 0. And then I'm going to rewrite that -3 as a plus -3. All right, I'm just rewriting it as a sum. So that lets us know that from here, we can see our vertex for this problem is 0, -3. So I'll go in and plot 0, -3. And then I'm going to identify my a value as 4. All right, so a is working as our slope. So we're going to go up 4 to the right 1. Now, because this is absolute value, we know that we're going to use the vertex point where it is, which happens to be the y-axis in this problem right here. That's our mirror, and we're going to plot the point that would reflect across that mirror. So that's how we'll get those 3 points. Plot the vertex, use the a to come up with the next point, and then use that mirror that runs down through the vertex to get a third point. Now, the lines, when we draw the lines in, they're going to only be dotted because y is greater than. So we're going to dot in, or dash, and then we have to shade. So since y has to be greater than, then you're looking at this y-axis here, and you can see that the only way you can get y's greater than consistently is if we go above that vertex. So we want all of that space shaded that's inside that V. For number 20, all right, if I'm writing it out, we've got to rewrite what's in the absolute value symbols as a difference of two values, because that's what our form says, a absolute value x minus h, and then that k is already written as a sum, so that's okay. Our vertex then we can see is -1, 2. So I'll go ahead and plot that. My a value is not recorded, and we know when the slope is not recorded, it has a value of 1. So I'm going to get a second point by going up 1 to the right 1. I'm going to look here at this line, vertical line that runs down through that vertex, and I'm going to use that as a mirror to plot the reflection of that second point to give me a third. Now in this case, we have a y is greater than or equals to. So because we have the equal sign in there, these are going to be solid lines. And the greater than sign is going to be indicated again by shading above, because we're looking at that y, the y axis, and we want all y's greater than that vertex point there. All right, let's look at a word problem. You have a summer job, and you offer to mow your neighbor's lawns for $20 or to wash their cars for $10. Your goal is to earn at least $1,500 this summer. They want you to write and graph an inequality that represents the possible number of lawns you would have to mow. They're going to call that X, so that's why it's labeled down here on your X-axis. And the cars you would have to wash, Y. So we're going to call cars washed Y. So we're going to write an inequality. Well, the expression to show how much you're making in lawn mowing would be 20 times X, however many lawns you mow. You'll add to that every time you wash a car for $10 and the number of those cars that you wash, Y. And now that has to be, if you're going to meet your goal, it has to be at least $1,500. So it could equal that $1,500, or it could go over that $1,500. We just don't want it to be less than, because that would mean you did not reach your goal. So that's your inequality. When you go to graph it, it's in standard form. So that, remember, that's when you have ax plus by is equal to c, your constant. When you've got it in that form already, and especially with a problem like this, the easiest thing to do is to find your intercepts. So that would mean plugging in 0 for x and calculating your y, and then plugging in 0 for y and calculating your x. When you do those calculations, you find out that when x is 0, your y value is 150, so that's your y-intercept. I'll plot that right here. And when you zero out y, you find that you've got an x of 75. So that's your x-intercept. All right, this is definitely the easiest way to do this problem. Okay, now once we've done that, we're going to connect our two dots with the ruler. And my line is solid because this isn't a greater than or equal to problem. So the solid line indicates the equals. Then we'll go in and shade all y's that are greater than are going to be over here on this side. So we want y's greater than that line. And so everything that falls either on that line or in that shaded portion is a solution to this inequality. That means that it is an answer to how many cars have to be washed and how many lawns have to be mowed in order for you to reach your goal. So in 23, they ask, what are the coordinates of mowing 50 lawns and washing 65 cars? Well, since we called mowing X and we call washing cars Y, then that coordinate point, so here's our ordered pair for that. And if you look up on the graph, in green here, I plotted that 50, 65. And so number 24 asks you, is the point in exercise 23, so what you did in number 23, 50 lawns mowed, 65 cars washed, is that a solution for the inequality? Meaning, is that going to allow you to meet your goal of $1,500 or more? And the answer is yes. It's actually going to allow you to meet it slightly over your goal of 1,500 because it on the line, any point on the line would give you exactly that $1,500. That would be equal to 1,500. Any point that is satisfied by it being inside the shaded portion is going to give you more than that 1,500. So this green point here, this 50 lawns mowed, 65 cars washed, is really close to that goal of 1,500. So you're not making much more than 1,500. But if you got up here into here in one of these points, way up in the shaded area, you're going to be making a bit more than that $1,500 the further away from this line you get. So the answer to 24 is yes.